Alright, so we're going to do a quick video here on linear regression inference. This is basically an extension of all the hypothesis testing we've been doing for the past couple weeks. Basically, we have the linear regression model, which is the standard y hat equals ax plus b, and on the AP you have to actually define what your x and y are. Another note is the correlation coefficient is r, and your r squared value is the percentage of points explained by the line. Basically, this is just kind of basic stuff you need to know. In any case, the easiest way to do any of this math is just you edit your list. You could either do your linear regression t-test, or you can do confidence interval, and it can actually do almost all the hypothesis testing or anything you need to do. You have to check for a couple conditions, of course, because the AP people are kind of assholes about it. Basically, you have to make sure that all the observations are independent, that the true relationship about the line is linear, the standard deviation of the response variable about the true line is the same everywhere, and the response varies normally about the true regression line. Whether or not they're actually going to check for all these conditions to see if you have them or not is debatable, but it's always better safe than sorry. In order to ensure that your line is acceptable, that your least squares regression line is okay, you need to look at the residual plot and make sure that all the points are scattered basically randomly about its line, and that's your residual y minus y hat. So now comes basically the nitty-gritty of the determining the confidence interval and the hypothesis testing. The easiest to work off first is the confidence interval. Once you get your slope of the sample, which is your b, it's basically going to be b plus or minus the t, which is going to be your confidence interval. So whether or not you're 95% confident or 99% confident, that's the number that you're going to put there, and your SEB, which is your standard deviation about that line. Our calculator does not give us the value outright, but in our reference tables there's a couple formulas that you can actually derive it in longhand form, but there's not enough time on the AP, and I checked it, they really don't care. That right there is what your SEB actually means, your standard deviation of all the points divided by the sum of basically all the variation that you have on the x-axis. So your confidence interval is actually really easy to solve. The calculator does it for you, and that's actually really nice to have. On to hypothesis testing, what we have is just standard deviation response, which is actually that S you see there is the S that we saw over here. That S is basically all of the deviations about the residuals. Your T statistic is your B over your SEB, and these are your hypotheses.